In part 2, we're going to keep working with the distributive property, but this time we're going to be using it to simplify algebraic expressions. And again, you'll start to notice here that the distributive property looks the same way or has the same format every time, and you can tell because it has a number directly next to the parentheses with two or more terms inside, and those two or more terms can be separated by either addition or subtraction. So in this case, we have 4 times in parentheses n plus 5, and when we use the distributive property, we multiply what's on the outside of the parentheses or distribute it evenly by each of the terms inside. So the first term is n, so we would do 4 times n. And then the second term would be times 5, so we would do 4 times 5. And then because it's an addition sign in between, we would add these two, we would add these two products together, and we would just simplify by doing 4 times n, which is 4n, and then plus 4 times 5, which is 20. And then we can't bring these two terms together because you can't add coefficients and variables to constants. So this would be as simple as we could go, or our simplified expression. Now part B does have a little something different in it. Again, we've got the distributive property because we've got the number directly next to the parentheses with 2 or more terms inside, separated by, this time it's subtraction. And when we go to distribute, we're going to notice right off the bat that when we multiply, it's actually 12 times 2y. So we haven't had very many opportunities to multiply a constant by a coefficient in a variable. And in part A, we said you can't add coefficients with variables to constants, but you can multiply them, because what this really means is we've got 2 y's inside our parentheses, and then we want to multiply that by 12 groups. So in the end, I'm going to kind of jump steps for a second, what we would end up having really is 24 y's, because we had 2 y's here, and then we multiply that by 12 groups for a total of 24y. And then we would, just to continue, again, distribute that outside number, the 12, by the 3, and we would have 12 times 3. And then the other thing we have to remember on this one to watch for is the sign wasn't addition in the first place, it was subtraction. So we would have to keep that going. So we would keep bringing that subtraction down. And then 12 times 3 is 36. And again, once you get to this step, we cannot combine our coefficients and constant, or our coefficients with the variables and a constant. So this would be our final answer here. For part C, we're going to continue using the distributive property because again we have a number directly next to parentheses that have 2, or in this case more, terms inside separated by addition. And we're going to start it the same way. We're going to distribute that 9 by multiplying it by each term. So in this case we would have 9 times 6. And then we would have that added to the second term, which would be 9 times x. And then we would add that to the third term, distribute that 9 equally for all terms, so 9 times 2. And then 9 times 6 is 54, and 9 times x can only go down as far as 9x because we don't know what x stands for, and 9 times 2 is 18, and we would add, again, all those things together. But this time you will notice that we can bring some more things together because we do have 2 constants. We have 54 and 18. So we can use some of those other properties that we've been talking about in 3.3 to get those constants closer together. And probably the most logical move right now would be to switch our 54 with our 9x, and that would be using our commutative property. And using the commutative property allows us to switch the order to put the 9x first, and then that would bring the 54 closer to the 18. And then we can use the associative property if we want to group the constants together, our 54 and our 18. And then we could just finish it off. Again, we can't really do anything with that 9x because it can't be added together with the constants, but we can bring 54 and 18 together, which equals 72, And so our simplified expression would be 9x plus 72. Here are a couple of on your own problems to try using the distributive property to simplify the expression. And just a heads up on this one, watch your signs carefully because we have some addition, some subtraction, and then one that we haven't tried together where you've got a little bit of addition and subtraction. So give it a try first, but remember, answers will be posted here so that you can check and see if you're on the right track. You might have already heard me mention in the video the phrase like terms, and by definition, like terms are terms that have the same variable. So for instance, they might have x's or y's, but they'd also have to be raised to the same power or exponent. So if it's just a variable like x, that's technically to the first power. We just don't ever write that. But if you had x to the second power, then that would actually be different than just x to the first power. So you couldn't really combine x and x squared or x to the third power, just like you can't combine x and y together. And we're going to practice doing that a little bit more, but we will be continuing to work on combining like terms here. So for instance, in an example like what we have down here, we've got 5 x's here and 2 x's here, and those are considered like terms because the x's just have a coefficient, but they don't have a variable, or in this case it would be like to the first power. So we would be able to bring those together using some of the properties we've been working on, and we could combine 5x and 2x to make a total of 7x's. And then, as we mentioned up here, constants are also considered like terms because you can combine those. So 19 and 2 could be easily brought together. Again, we'd switch them around using some of the properties, but 19 plus 2 would be 21. So we could simplify this expression by combining all of our like terms. And I'm sure you've already noticed that we're going to be skipping example 4 for right now. It's a real life application and we'll get plenty of practice with that. But in example 5, we're going to keep practicing the idea of combining like terms to simplify each expression. So for letter A, we've got 3x plus 9 plus 2x minus 5. And right off the bat, we can start noticing where we have like terms. So we've got a couple of variables with coefficients, and they're both x's to the first power, or just x, because there's no actual exponent there. And they have coefficients, but they're still x's with no extra variable or no extra exponents. So they're things that we can combine. And then we have a couple of constants here, which we could bring together. So we're going to use the commutative property. We do have to be a little bit careful because there is some subtraction involved here. We can't normally use the commutative property with subtraction, but as long as we make a smart move and we just move within the addition signs, then it will still work. So the most logical thing to do here is going to be to switch these two terms around, the 9 and the 2x, because then we just have the addition still and we don't have to mess with the subtraction. And so if we do that, then we would be moving our 3x, or excuse me, keeping our 3x there and moving the 2x closer to that, and then moving the 9 after that, and then just leaving the minus 5 there at the end. And again, we can do that because of the commutative property of addition. And then we're going to start working on combining our like terms. And for this one, I'm going to show you why it fits with the distributive property. They teach you to kind of think of it like the distributive property by thinking about the coefficients here and kind of pulling those coefficients out and saying it's the same thing as 3 plus 2, and then taking each of these x's and then just kind of saying it's like multiplying 3 times x, because that's what 3x means. So 3 times x, it's like the distributive property in reverse. And then 2 times x, which is really the same thing as 2 times x. Again, kind of like the distributive property in reverse. So we're not going to do it like this every single time, but at least I want you to know why it fits in the distributive property section. And then for the rest of it, we would just go on to add the 9 minus 5, which again, we're going to simplify that in a second here. And so technically this is all done kind of as a result of using the distributive property, but sort of backwards from what we were originally doing with it. And then once you have it here, then it's pretty easy because you're not going to redistribute, because again, we went backwards, but we're not going to redistribute these numbers. We're just going to add in parentheses here the 3 plus the 2, which is 5 times the x. So again, another way to think of it earlier was just 3x's plus 2x's, but this is why that works. So 5x plus 9 minus 5, which is 4. So our final expression here would be 5x plus 4. And again, for part B, just to continue using the distributive property and knowing why we use it, we've talked about hidden coefficients in variables like this. So you've got y, which is technically the same thing as 1y each time, plus 1y, plus 1y. So kind of like what we did last time where we took the thing that they had in common, which in this case they have all those y's in common, and then all of those 1's could be added together. So 1 plus 1 plus 1 times the y each time, because we had 1 times y, so 1 times y, 1 times y right here, 1 times y right here. Another way to think of that is 1 plus 1 plus 1 is 3 times y. So our simplified expression, which again, when you've been doing this for a little while, it makes sense to just say 1y plus 1y plus 1y equals 3y's. But just like we've been working on for the rest of Chapter 3, we're just trying to make sure that you understand why it works that way using the distributive property. For this last one, we've got 7z plus 2 times z minus 5y. And again, this should look like the distributive property to you by now. Number directly outside the parentheses with 2 or more terms inside separated by addition or subtraction, in this case subtraction. So for this one, 7z is staying the same. And then we're going to use the distributive property like we did in all of our earlier examples to distribute 2 times z. And then be careful, watch your signs. This is a subtraction one. And then to distribute 2 times the second term, which is 5y. So 2 times 5y. And that is, again, because of the distributive property. So we're just kind of naming our steps along the way for right now to make sure that we know what we're doing. And then when we go to continue combining them, we can see here that when I start to simplify, I've got 7z plus 2z minus 10y, because 2 times 5y is the same thing as 10y's altogether. And then you can kind of see that these are both z's with different coefficients, but they're to the same power or exponent because they don't have an exponent up there, which means they're to the first exponent. So we can add those together. So 7z plus 2z would be 9z's altogether minus 10y's. And even though these both have coefficient and variables, because they're different variables, we can't bring them together. They're not like terms because they're different variables. So this would be our final simplified expression. For the answer for this first one, I just want to make sure you're very clear on it. So we had 8 plus 3z minus z to begin with, and when we're combining like terms, we do still have to pay attention to the operation symbols that are close to them. So even though we've got 3z's here and 1z here, when we're combining them, it actually asked us to subtract one of those z's from the 3z's, so we end up with 8 plus 2z as our final simplified expression.